Okay, we're going to start week 10. Week 10 has some more applications of derivatives, so we're getting close to the end here with derivatives. So what these pictures are, these are word problems. So we had word problems in a thing called related rates, and these are called optimization problems. So if you remember, when you set a derivative equal to 0, that gives you the highs and the lows, the mins and the maxes. So now what we're going to do is we're going to use that same thinking, but apply it to kind of like a real life problem here. So we're still taking the derivative and we're still setting it equal to 0, except when we solve for some values, it's actually going to mean something rather than on a curve. So in the first one has a box there, and lots of times with the box, it has an open. It's open on the top, which is very common. So you can kind of see that in the box that's kind of shaded there. So what you want to do is you want to make this box the biggest you can. So you want to maximize the volume, but you only have a certain amount of material to make the box. So depending on which way you make the box, it could have different volumes. So you want to make this the biggest volume you can. So the volume is the thing you want to maximize in this case. So whatever you want to maximize or minimize, that's the one you need to write a formula for and take the derivative of. So the volume of this box, according to our picture, is length times width times height. So the volume is the length is x, the width is x, and then the height is h. So x times h is x squared h. Okay? So now you notice once again we have three variables here. So just like in the related rates problems, usually what you want to do is you want to get rid of one of the variables. So what they usually do is they give you another formula. So they actually tell you something about the surface area here, which is the amount of material it's going to take to make this box. So the surface area formula for this box, surface area is just the area of all the pieces, and then you just add them all together. So the area of the bottom is x times x, which is x squared. And then you can see all of these sides. It has 4 sides, and the area of each side is x times h. The top doesn't have anything because it's not part of the box. It's an open box, an open top box. So what they do is they tell you the surface area that this material is 108. So what you can do now is you can do some algebra here at the bottom to solve for h pretty easily. So it's 108 minus x squared, and then if you divide by 4x, you get h. So what you can do now is you can simplify that a little further. 4 goes into 108. So basically what you're doing is you're doing a little long division here with this one. So when you do that little long division, you get 27 x to the negative 1, and then minus, when you put that in there, when you put the 4x over the x squared, you get 1/4 x, like that. Okay, and that equals h. So what you're going to do now, before you take the derivative, you're going to get rid of one of those variables. So now, for h, we can have 27x to the negative 1 minus 1/4 x. And then, just like you did before, always simplify before you take the derivative. Okay? So now, you want to figure out your maximum volume you can get based on this area, the surface area of 108, which is the amount of material you have to make this box. So now what you do is you take the derivative. So the derivative of v, we'll just call v prime. That's something that you want to maximize. And then usually you have x's in there or just one letter. So you take the derivative just like you normally would. So the derivative of 27x is 27. And then the derivative of this is 3/4 x squared. And then in order to minimize, or in this case maximize, you just set your derivative equal to 0. and then you solve. So the 27 goes to the other side. It's negative, and the negatives cancel out. And then you multiply by 4/3. In this case, I believe you get 36. So x now can actually be plus or minus 6. So that's going to help you figure out the dimensions of the box. Now, remember, you got two answers here. So one of them will maximize the volume, and one of them will minimize the volume. So you can see that we're really never going to have a length of -6 in this case. So that's kind of like a curve kind of thing, where -6 would be the bottom of the hill of that curve, of this curve actually. This is actually a curve here. So the only one that really works is the one that's positive. So lots of times you will get two answers, and you have to figure out which one makes sense for this real application here. So in this case, x is 6. So then what you do is you have to plug 6 back in this formula here to figure out h. So to figure out h, you do 108 minus 6 squared, which is 36, over 6 times 4 is 24, to give you h in this case. So when you do that, calculator out here, I think it comes out even to a certain number. Sometimes you will get decimals in this case. Yeah, so h is going to be 3 then. So you go back and look at what the question's asking. Usually it asks you for the dimensions of the box, or it might ask you for maybe the volume of the box now that you know the dimensions. So let's see, go back. It says what dimensions will produce the maximum volume. So the dimensions of the box will be 6 by 6 by 3. So the length and the width are 6 and the height is 3. So that in general is how you do a minimum and maximum type of problem. Sometimes you have two equations and you got to get rid of one of the variable. Other times you just have one equation and you're good to go. So this one here, this is a very type of popular problem. So this one, what you're doing is you have a piece of cardboard, okay? And the piece of cardboard is 4 by 3. So in order to make this into, this should be an open top box, same kind of thing. What you're going to have to do, and I don't know if you knew this or not, is you actually have to cut little squares out of the box. So when you cut squares out of this piece of cardboard, it's flat now. So when you cut squares out, okay, each of them have to be x by x. In order for you, if you kind of think you got to fold these edges up. So when you cut this out here in this corner, when you fold the edges up, it'll actually make a nice little box. Now the top will be open, but it'll make like a nice little, kind of like a tray almost, with some sides on it, okay? So in this case, you want to figure out, you only have this 3 by 4 piece of cardboard. You want to figure out, okay, what's going to give you the maximum volume of this open top box based on the dimensions of this little square that you have to cut out so you can make it up a box. So you'd actually have to kind of tape up the sides here a little bit, but you can try it with a piece of paper if you want. Just cut some boxes out of the corners and fold it up. So once again, the volume of this box is length times width times height. So now we got to put in some formulas. So the length isn't going to be 4 anymore. It's actually going to be 4 minus 2x, because you're going to cut a little square out. The width was 3, but now the width isn't going to be 3 anymore. It's going to be 3 minus 2x. And then the height, when you fold these sides up here to make a box, your height is actually going to be x. It's going to be whatever the dimensions that you cut out of that box. So now this one's a little different because you can see you only have two variables. You have the volume and you have this x, which is the side lengths and so forth. Okay, so this one you don't have any other variable because you know the piece of cardboard you have. It's kind of a given thing. So what you do then is you're going to multiply this all out. So when you multiply this all out, you get 12x, and then in the middle you get 6x and 8x. It's going to be negative, so that should be a negative 14x squared. So you're multiplying the x through at the same time. And then 2x times 2x is 4x squared, so it'll be 4x cubed. Okay? So now, when you do this one, you only have two variables, so you're ready to take the derivative. So the derivative of v is v prime. That's what we're trying to maximize here. We're trying to get the largest volume. So I'm just going to rearrange these as I take the derivative. So the derivative of 4x cubed is 12x squared. The derivative of 14x squared is negative 28x. And then the derivative of 12x is 12. So hopefully when you set this equal to 0, it factors. So now we'll see if this factors, if I did the derivative right. Most of the time it does factor. If it doesn't factor, you have to use the quad program, a quadratic formula type of program, which is fine. The one on the test, if you get ones like this, it will work out nice and even when you factor it. So in this case, you actually 12 out of the 28, so I have to go back here and reverse that. So the biggest number it looks like you can take out is probably a 4. So I don't know if this will factor or not. Sometimes these problems factor and sometimes they don't. Like I said, if they don't, you just have to use the quadratic formula. There's quadratic formula solvers on computers and stuff, so I wouldn't bother to actually do the quadratic formula. I would just kind of punch the numbers in and do that. So this is 7x and that's squared, and then you take and you get 3. So I have to look at my answers to see if this factors here. If not, you would just do quadratic formula to figure out the answers. All right, so let's see if this one factors. No, this one actually doesn't factor. Okay, so this one you'd use the quadratic formula, and you would get 2 answers. So now it's kind of important that you make these into decimals or something like that. So you'll get actually 2 answers here. So now you have to figure out which one is actually the right answer. So now if you plug in, first of all, this number 1.77 into here to figure out some dimensions, you'll notice if you plug it in for the width, if you do 2 times 1.77 and then you subtract that from 3, you actually get a negative number there. So in this case, this one will not work. This one will actually give you the minimum volume in that case. So this one, this little box that you're going to cut out is going to be 0.57. So that's going to be the height of it. So to figure out your length, your width, and your height, you just plug 0.57 back into here. So 4 minus 2 times 0.57 will give you that dimension. So if you grab your calculator, and like I said, the ones on the test will work out nice. So you do 4 minus and then 2 times 0.57. You get a length of 2.86. And then you do the same thing with the width. You take 3 minus that. So 3 minus and then 2 times 0.57. And you get 1.86. And then we said the height, which is going to be this 0.57. And all of them, this is actually feet. All of them are actually feet. So that's a very popular problem where you have a piece of cardboard and you cut the edges out there. All right, the next one is another popular problem that you have some type of farmers building a fence. So here's your fence. It doesn't really matter kind of which way your fence goes. Now, it's important to read the problem because this borders a river. So where the river is, for whatever reason, you're not going to need any fencing because it tells you that. Okay, so no fencing is needed on the side of the river. So you can give your pen some lengths here. So whatever you want to use for the variables, but it's rectangular, so these have to be the same length here. Okay. So it says, what are the dimensions of the fence that gives you the largest area? So in this case, you want to figure out the largest area. So this is the formula you want to take the derivative of. The area of this thing is length times width, or x times y in this case. But you also have another thing here. You have the amount of fencing you need. So fencing has to do with perimeter. That's all the way around if you put the fence all the way around. So the perimeter of mine is this. It's x plus 2y. And we know the perimeter is 2,400. So now what you can do is you notice the equation that you want to take the derivative of. Once again, it has 3 variables and you only want 2. So down below here, you can solve for a variable really, really easy. So 2,400 minus 2y equals x. So then what I'll do is I'll go back to the area formula. Here's an x, here's a y. I'm going to put in 2,400 minus, whoops, we have to do it the opposite way. We've got to get rid of the x's, or the way I have it. So for x, we got 2,400 minus 2y, and then times a y there. Okay, so now we have all y's. So it doesn't really matter what variable you solve for, but make sure you simplify. 2y squared. So now you take the derivative. So the derivative of a is a prime, or whatever you want to call it. And then you take the derivative of y just like you did with x. So the derivative here is 2,400, and then minus 4y. And then to maximize your area, you set your derivative equal to 0. And then when you do that, you know, you can probably do this in your head. Y is 600. Okay. So then what you do is you go over here and you figure out your x value of your fence. So you do 2,400 minus, this will be 1,200. So 2,400 minus 1,200 is 1,200. So that'll be your x value. So you just plug it, you know, back in there, the x value. So that's a very popular problem where you're given an amount of fencing and you want to maximize the pen. The last one here, I believe, this one's a little bit harder. This math, you can see I left the whole page for this one. This one's a little bit harder. So this problem here, what you have is you have 4 feet of wire. So that's kind of about, that shows you something about the perimeter in this case. So what you want to build from this wire is you want to build a square. Okay, so here's our square. So our square is going to look like that. All right. And the other thing we're going to build besides a square is we're going to build a circle. So now a circle has 2 formulas here, kind of. We're talking about the area of a circle eventually, and we're talking about circumference. Okay? So now the 4 feet of wire is the perimeter. So that's one of the formulas that we have. We only have 4 feet. So what we want to do is we want to figure out the total maximum area of these 2 things combined if we only have 4 feet of wire to make both of these things. So the perimeter of our square is 4x. And then the perimeter of our circle is 2 pi r. So circumference means perimeter. So in this case, we have 4 feet of wire. Our perimeter is 4 feet. All right. So now eventually what we're going to do is we're going to get rid of one of the variables, okay? Because our area formula for this that we're going to use to figure out our total area is the area of our square is x squared. The area of our circle is pi r squared. So if we want to maximize the area, this is the one we want to take the derivative of. You can see there's 3 variables. Now pi is not a variable, it's a number. So what you can do now is, what I would do is I would probably solve for x over here. So it doesn't really matter. This one is kind of messy. Either way you do it. So I'll solve for x there, okay? and now I'll get rid of the x's. So now this is where it's very algebra intensive, because when you sub this in, you have to square this thing. So before I sub it in, I'm going to do a little long division. This 4 is going to go with this 4, so you actually have a 1, minus this 4 also goes with this thing, so you have 1/2 pi r for that one. So that equals x. So this is the formula I'm going to plug in. So 1 minus 1/2 pi r, and then squared, and then plus pi r squared. So this is why this one's difficult, because in order to get this formula where you can take the derivative, you got to do a lot of math here. All right, so the area is, you're going to square this, you're going to FOIL it. So it's actually 1 and then minus pi r and then plus 1/4 pi squared r squared plus pi r squared. So this is a 1 here, disappeared. So when you FOIL this, you have to write it twice. You should get this kind of messy formula here. So now you're actually ready to take the derivative. The derivative of a is a prime. Derivative of 1 is 0. So now this one, think of r like an x. The derivative of negative pi r is negative pi. This one here, the derivative of this one, 2 goes times 1/4, which is 1/2. Pi squared comes along because it's a number, and then r goes to the first power. So think of that as like an x squared, plus 2 times pi is pi, r goes to the first power. Okay? All right, so now in order to figure out your r, and you're going to get probably a weird equation for this, what you're going to do is probably factor a pi out. That's probably what I would do first. Set it equal to 0. So when you do that, you get negative 1 plus 1/2 pi r. And then factor a pi out here, you get 2r. Okay? So now when you set this equal to 0, this is a number like, 0 equals pi. You're not going to get any solution for that one. Okay? So the next one is this one. 0 equals negative 1 plus 1/2 pi r plus 2r. So now the way you solve this one is you add the 1 over, and here what you're going to do is you're going to pull an r out. So then r is this really weird formula. Okay? This is r. So now what you can do to make r look, that's fine if you want. You can multiply top and bottom by 2 to get rid of the fraction. So if you do that, if you multiply the top by 2, you get 2. If you multiply this whole bottom by 2, you get pi plus 4. So that's another formula for r. Okay, so either one is fine. If you want to make it look a little nicer, that looks a little bit nicer. So you can see that one was really algebra intensive. So now the only thing left to do is to solve for x. So if you go back to your original formula here that you had for x, and then we're pretty much done with this problem, is here is r. All right, so your x is 1 minus 1/2 pi. So now you plug this guy in for r. So I'll use the one that's a little bit nicer, pi plus 4 equals x. Okay, so x is going to be kind of the strange formula. So actually when you simplify this, since it's multiplication, this 2 and this 2 on the bottom actually cancel. So on the top, you're actually just left with this pi, and then the bottom you're left with pi plus 4 equals x. So that's pretty much what you can do there for that one. So the 2's cancel, and then you have a pi left on top, and then you have that on the bottom. So that's pretty much what x is. So those are the dimensions, and you can actually figure out what it would actually be, okay? So one more thing before we stop the video is this Newton's method is one more type of problem it's an application of derivatives, okay? So what you're trying to do here with Newton's method, this is a totally different topic. And this is where you might need a little bit of a calculator also for this particular problem, is you're trying to figure out where this crosses the x-axis. So what you're trying to figure out is you're trying to figure out what value of x gives you a y value of 0. Because that's where it crosses the x-axis. That's what it means, where y is 0. So you're trying to figure out the x value when y is 0. So what Newton discovered is he actually did, it's called iterations, and he had a little formula here to try and figure out eventually where it's going to cross. So I know you could punch this in a calculator and kind of figure out where it crosses, but what you're going to do is you have to start out with a guess. So in order for everyone to kind of get the same answers, we always start with the same guess. So our first guess here, to figure out if when y is 0 is x equals 1. So if you plug in 1 in here, you're not going to get 0 exactly, but that's the guess we're going to start with. So then to find your next guess. So your first guess is x of 0. So your next guess we're going to call x of 1. Okay? So what you're going to do is you're going to follow this little formula up here. And x of 1, your next guess, is based on your first guess. So here's the formula. So your next guess, which is x of 1, you start out with your first guess. All right? And I'll actually kind of write this little formula here. And so you're going to start out with your first guess, and then you're going to subtract, putting your first guess into the function, divided by putting your first guess into the derivative. Okay? So this little formula with this first guess will get you your next guess. It'll get you closer to the correct answer. All right? So we're trying to figure out x of 1, which is our next guess. So our first guess was 1 minus, so now you put 1 into the function. You put 1 into the function. Here's the function. And then what you do is you put 1 into the derivative. All right? So here's our function, x cubed minus x minus 1. Here's our derivative, 3x squared minus 1. Okay? So now 1 minus, you put in 1 into the original. Okay, so if you put 1 into the original, you get 1 minus 1, which is negative 1. And then you put 1 into the derivative, you get 2. So then our next guess is 1.5. Okay? All right, so now we're getting a little bit closer. So the x value that's going to give you a y value of 0, now we think it's 1.5. We originally thought it was 1, but based on this Newton's method, now it's going to be 1.5. So now we'll do this one more time. So what will happen is you'll get closer and closer to the correct answer as you do this. So our next guess, number 2, is based on guess number 1 now. So now we use this guess, 1.5 minus, and I'll just use plug in 1.5 into the original and plug in 1.5 into the derivative. Okay? So you get 1.5 minus, okay, so now you have to plug this, use my calculator a little bit, and here's where you kind of need a calculator. So you punch it in the original, so 1.5 cubed minus 1.5 minus 1. It equals. All right, so this number is 0.875. So now you plug in 1.5 into the derivative. So 1.5 squared times 3 minus 1, right? So this number is 5.75. All right, so now this one you definitely need a calculator. 0.875 divided by 5.75. And then you want to take that number and subtract it from 1.5. All right, so you get 1.34, and then I'll round to an 8. So now the x value that we think is going to give you a y value of 0 is this number. So this number actually, if you actually solve this, is getting very, very close to this answer. I don't have the real answer on my paper, but this value of x, if you plug it in here, you're going to get something very, very close to 0. So what happens is x of 3 now would be based on this number, and you would get even closer to your answer for that one. Okay? So I normally only want you to do up to iteration number 2. Okay, but this process can go on forever, and you will get very, very close to the right answer. Usually by this try, usually by the second try or the third try, you'll actually get very close to the next answer. So what I have here is I have one other problem that's almost identical, except it uses x as -1. So this one, the original equation is x squared minus 2. So the derivative is 2x. So this one we start with a guess of -1, right? So our next guess is we're going to use -1 minus, and then we're going to plug -1 in the original, and then we're going to plug -1 into the derivative, right? So -1 minus, plug in -1 into the original, you get -1. Plug in -1 into the derivative, you get -2. So this one looks like it's going to be -1.5, I think, again. Well, the other one was positive 1.5. Yep. So now we'll do this one more time. So now our second iteration, you're going to use this next guess of -1.5 minus. So now you put -1.5 in the original, and you put -1.5 in the derivative. So here we go, -1.5 minus, right? So now I'll have to use my calculator. So 1.5 squared minus 2. So this one you get positive 0.25. And then you plug in -1.5 in the derivative, and you get -3. So this will be actually a positive number now. Okay? So 0.25 divided by 3, that'll be positive. So you add that to -1.5. All right. So now the number becomes a little closer, -1.41, and then we'll call it 7. So when you put this number into there, you're going to get something very, very close to 0. And this one we can actually see that actually the square root of 2 and the negative square root of 2 actually give us our answers there for where y is 0. So the square root of 2, if you type that in your calculator to actually get you the real answer, is positive or negative 1.4. So the square root of 2 is 1.4142. And you can see, now this plus or minus, you can see already, you know, how close we got to the answer just on the second iteration. Now it's negative. We got the -1. There's 2 answers here. So in order to find the other answer, you probably would start with a guess of +1 and that kind of thing. So now I will always give you the first guess on this kind of thing because if everyone uses a different guess, you'll get different answers for x of 1 and x of 2 and so forth. Also, too, if you don't start with a guess that's actually close enough to the correct answer, Newton's method won't actually converge on the right answer. It'll actually go back and forth between numbers, and it won't converge very nicely. So your first guess kind of has to be close to the right answer in general. So that's another type of thing. that we have here for an application of derivatives. It's called the Newton's method. So what I did next is I have a whole bunch of homework problems here that are the min and max problems. I assigned some book problems on the back here. So the back, there's other book problems there on page 260. So that kind of completes it for week 11 and 12, which is kind of short in that case. Okay, so that's it.